Welcome to our first GMM of the new year. Good to actually see people in person. It's really awesome. So today's presentation, Oahu sea level rise. I'm really excited to see a good turnout and people online. Our presenter today is Interim Dean of School of Ocean and Earth Science and Technology at the University of Hawaii, Dr. Fletcher. And thank you, of course, to our sponsors. This presentation is certified for one health, safety, welfare credit, through AIA. So if you haven't already put your number in and you need credit, let them know. And we have sort of two announcements before we get going. The first is our kickoff for 2023. It's going to be February 2nd over at the Hub Cowork Oahu. And 5 p.m. Talk to us about committees, sign up for things, give us ideas for what you want to have happen in the next year or so. And then AIA 2030, which is free. So come join us for all the presentations, 10 sessions over the course of about a couple of months. And should be really good. Lots of interesting stuff coming up. And
Evergreen by Deborah is a distributor of ceramic and
Evergreen
glass
by
tile,
Deborah.
art and images in hard surfaces, 100% permeable pavers and planters. Here are some of our product categories and most favored vendors. Ceramic panel facade systems and tunnel tile by Agra Buktal. Clay brick and brick pavers by Endicott. Ceramic wall tile and porcelain floors with C2C LEED Gold certification by Royal Musa. Recycled terrazzo by Trend USA. Glass tiles from Interstyle. 100% permeable interlocking concrete pavers with hydroflow technology. Large format porcelain panels from Iris Italy and Iris USA. Hydroflow, the only truly 100% permeable concrete interlocking paver made today. Pavers made with hydroflow technology include 48% post-industrial recycled content. The installation of hydroflow is similar to other standard pavers, and there are many shapes and patterns to choose from. Similar to other pavers, hydroflow technology pavers are installed over a crushed stone permeable bed. Hydroflow pavers are installed over 700 driveways and partial driveways at Island Palm Community Army Military Residential Housing here on Oahu. The installation of hydroflow pavers helps to protect water, our most valuable resource, where it's allowed to return naturally to the aquifers below. Please let us know how we can be of service to you and your client. Mahalo.
Let me tell you what I paid him.
Great. Thank you, everybody, for coming and sharing your lunch with me. In addition to being interim dean of SOEST at UH Manoa, we also have now a 2-year-old research team called the Climate Resilience Collaborative. This is our first annual report. We are doing new wave modeling with sea level rise, coastal erosion with sea level rise, groundwater flooding with sea level rise. We're installing monitoring wells in the drainage network culverts throughout Waikiki and into Kaka'ako. We're trying to track down basically every drop of water from the ocean and from rain and runoff in the sort of coastal lower region of Honolulu. We will be expanding our research statewide, and our ultimate goal is to push products out on a publicly available online viewer showing the extent of these various forms of flooding and land loss at 1-foot increments of sea level rise. You may be familiar with the Hawaii sea level rise viewer. We hope to replace that with this more expansive, better modeling, better physics, and more granular or detailed type of modeling with our CRC group. So again, there's an annual report over there that describes some of this. My talk is going to have basically two parts. First, I'm going to go into global climate change. I want to give you an update on the salient issues there, sort of where we stand so far. And at that point, I'll take a short break and entertain any questions, and then we'll move into sea level rise, both globally, locally, and then we'll end up talking about the new proposed setback that the Honolulu City and County is proposing. Bill 40 and Bill 41. I think it's Bill 41. This is the actual setback. So this is data from NASA. Each black square represents the average annual surface temperature of planet Earth. So it is aggregated from lots of measurements, including the ocean, beginning in the late 19th century. Notice that prior to World War II, there was a strong uptick in global warming. But then with the incredible manufacturing that occurred with World War II and also following World War II in the 50s and 60s, there were not any clean air rules, and the manufacturing was very dirty, spewing aerosols into the atmosphere, which blocked sunlight and actually temporarily stalled the increase in heat until a whole series of clean air laws were passed by the United States, which were then followed by other industrialized nations, right up to the past decade, where China is passing and has passed significant clean air laws. All of this allowed more sunlight to hit the planet. It's called global brightening. And with that increased sunlight, we saw global warming really take off. Earth's surface temperature really accelerating from this period. And we're worried that there is an additional acceleration happening in the past several years. We've had 3 years in a row of a La Nina in the Pacific Ocean, which tends to create cooling conditions. But the early signs are that that's coming to an end, and we can start to look forward to an El Nino. Whether it's a powerful El Nino or not will make a lot of difference to us here in Hawaii, and in fact globally. But the projections are that if and when that El Nino takes hold, we may look at another acceleration in global warming, perhaps reaching beyond 1.5 degrees Celsius. So far we have warmed 1.1 to 1.3 degrees Celsius above the pre-industrial period. That may not strike you as very much, but there are systems in the world that are highly sensitive to small amounts of temperature change. Your body is one of these. An analogous temperature to warming of this amount in your body temperature would give you a low-grade fever of about 100 degrees Fahrenheit or 101 degrees Fahrenheit. You probably wouldn't come into work that day. We're currently on path to warming to 3 degrees Celsius, which is a vast improvement over what we were projecting 10 years ago. But 3 degrees Celsius is equivalent to a high-grade fever, analogously. After several days of a high-grade fever of 105, 106 degrees, if it doesn't go down, you start to suffer organ damage. So Earth's surface is highly sensitive to small amounts of temperature change. Don't let those low numbers fool you. 2022 is coming in as the 4th to 6th warmest year on this record, depending on which agency or academic group is doing the reporting, but they are generally in agreement. And each of the last 8 years has been hotter than any year prior to 2015. This past summer, we saw one right after another extreme weather event. Here we have over 100 million Americans under heat warnings earlier in the summer. We are in living hell in Pakistan and India. This is a warning for Spain, devastating blazes and heat waves, record heat. Is there any way you can raise the dashboard up there? Record heat waves creating an energy crisis. Thanks. That'll probably get in the way later. Maybe that's what I can minimize it. There you go. Thank you. China's unrivaled 70-day heat wave, looking back through diaries that exist over 1,000 years ago. They experienced an unrelenting heat wave where the world's third largest river essentially dried up. In China, California heat waves smashes monthly and all-time records. So these heat waves are coming with greater ferocity as we warm the planet, and floods are coming with greater ferocity. All of these were from this past year. Brazil, thousands displaced with rain and floods. Climate change exacerbated heavy rainfall in West Africa. Pakistan lost 1.7 million homes and 1,400 deaths. 1/3 of the country, literally, the footprint of flooding covered 1/3 of the country. So we're seeing extreme weather events, which basically is weather on steroids because we have warmer air, even that small amount. I wanted to make sure and give you this projection. This is from the Proceedings of the National Academy of Sciences. Today, these little black spots in the center of the Sahara Desert and the shore of the Red Sea are considered too hot for human existence. This land area represents less than 1% of Earth's surface, but with warming of 3 degrees C, which we, even with our decreased emissions of the last several years, we are on a pathway to warm about 3 degrees C. We're going to see these conditions expand to about 1/5 of the land surface, too hot for human existence. In other words, everywhere that you have these diagonal dark brown lines is a statistically significant model result. This is over 36 climate models all coming together, and this is forming their aggregate results, meaning that there's a significant number of these models that are projecting even higher results and a significant number projecting lower results.
Excuse me, can you define the time frame that we're talking about here? Because
This century,
this century, so by this is the 3 degrees is by
the 5th century, it's before the end of the century.
Okay.
At today's warming, we will expect to see 1 billion people displaced for every additional 1 degree C of additional warming. So warming like this makes food and water security. It threatens food and water security. It upsets the stability of communities, and it can drive migration, family migration. This is the carbon dioxide record from here at Mauna Loa Observatory. Early in the collection of CO2, the rate of increase was less than 1 part per million per year concentration. And in the last decade, it's averaged 2.4 parts per million per year. So the rate at which CO2 is accumulating in the atmosphere is not linear, it is accelerating. We're now up to about 420 parts per million, which is more than a 50% increase over the natural level of CO2 in the atmosphere. Pre-industrial, it was about 278 parts per million. More than half of all industrial CO2 has been emitted since 1988. When NASA scientist James Hansen in July of 1988 testified before Congress, US Congress, and said global warming is real, it's here, it's having an impact, and we can see the effects. 40% of the CO2 we emit today will still be in the atmosphere in a century, and about 20% will still be there in about 10,000 years. Nature is not pulling down our CO2. We need to pull it down. You've all heard of mitigation and adaptation. Well, sequestration is the third pillar of dealing with this problem. We need to deploy mechanical devices around the planet. A rough number is basically one where today every gas station is located that can pull CO2 out of the air and sequester it. That's actually a huge investment opportunity. Methane has become a major problem. Methane emissions have set records each of the last 3 years. Methane is responsible for as much as 1/3 of near-term global warming. It's 25 times more powerful in trapping heat than CO2. If you look at the carbon isotope chemistry of this methane, we find it is not coming from burning fossil fuels. It is coming from wetlands where the microbe community is breaking down organic matter faster and faster. In other words, nature is responding to the heat that we've put in the air. It's not obvious to any of us, how we can stop this, other than stopping the warming. This is a natural system that seems to be taking off on its own. Another form of this methane is comes from fermentation, enterotic fermentation from cattle. So as we feed cows corn, they're grass feeders, grass grazers naturally, and as we feed them corn, their digestive system gets upset, and they are responding by emitting huge sources of methane. In fact, satellites actually see methane spikes as they pass over feedlots. There's that much methane coming out, both from the cattle themselves as well as the fertilizer. So in response to all this, the United Nations has created a division called the Framework Convention on Climate Change. They hold annual meetings called COPs, Conferences of Parties. The COP in 2015 was held in Paris, and significantly at this time, eventually all of the world's nations signed on to a charter agreeing to reduce their emissions sufficiently to stop warming before it reaches 2 degrees Celsius. And at the urging of the small island nations of the world, they also signed on to a pledge to pursue efforts to end warming before 1.5 degrees Celsius. A report came out in 2018, a few years later, telling us what the world will look like at 1.5 degrees Celsius. Extreme weather events, continued sea level rise, species loss and extinction, the oceans suffering, the marine ecosystem suffering, increased disease, decreased food and water security, decreased human safety. With this report, 1.5 became the new target. And that is the focus of negotiations now with continuing COP meetings. The most recent one was in Sharm el Sheikh in Egypt. So the question is, how are we doing in stopping global warming at 1.5 degrees Celsius? So on the bottom axis, we have the first half of this century. On the vertical axis, we have carbon dioxide emissions in billions of tons or gigatons. This is the history of CO2 emissions up until including 2019. 2019 was the record. And then we went into COVID recession. We saw a decline in CO2 emissions of about 5.4%. And in 2021, with the release of government stimulus around the world, we saw emissions take off again as the economies came back and we came out of hibernation. The increase exceeded the decrease. So 2021 was a new record high for CO2 emissions. We don't see the final numbers yet for 2022, but a few months ago, the projections were that we would see a 1% increase in CO2 emissions last year. Remember, we need to decrease emissions to stop warming. That's the pathway. And this means we need to have net zero emissions by mid-century. When you add up all the promises of the world's nations, the pledges under the United Nations framework, we're on a pathway to warming of about 2.5 degrees Celsius. Those are the pledges or promises. But when you actually quantify the policies and the investments nation by nation, it puts us on a pathway closer to 3 degrees, 2.8 degrees. This represents a gap. And every year, the United Nations comes out with what's known as the gap report. It comes out in November or December, the same time that they have their annual COPs or meetings. And the most recent gap report says, IPCC, this is the Intergovernmental Panel on Climate Change, which is an organization that takes scientists, hundreds of scientists who volunteer from around the world to update the latest science and the latest modeling. The latest models indicate that emissions need to be cut by 45% by 2030 compared to 2010. But current commitments in the form of investments will increase emissions by over 10% by 2030. Result is that this report states that there's now no practical pathway to stopping warming before 1.5 degrees Celsius. But there are other factors at play here. For instance, on average, emissions are underreported by 23%. That's not taken into account in the UNFCCC calculations. And there's another factor which is even more worrying. So let's take a look at CO2 emissions annually. About 86% come from burning fossil fuels, and about 14% comes from deforestation and poor soil husbandry, poor soil conservation. The world's agriculture fields are a massive storehouse for carbon. But when we leave them exposed to the air and we plow them with deep furrows, they oxidize and CO2 comes streaming out of these soils. There are other more regenerative ways of farming using cover crops and no-till farming that allows the carbon to remain in the soil. In fact, it can put more carbon in the soil. Unfortunately, that's not widespread yet. Of this CO2, about 46% goes into the air, trapping heat that would otherwise escape to space, causing warming. About 31% is pulled out of the air by photosynthesis, stored in the terrestrial plant community. And about 23% of this CO2 is dissolved in the ocean. H2O plus CO2 makes H2CO3, which is called carbonic acid. It's a very light acid. It interferes with the precipitation of coral exoskeletons, of bony fin fish, of the precipitation of their bones. It interferes with our skeletal system. If you drink too much carbonic acid, like in your favorite Coca-Cola, your 7-Up, you know, all the CO2 in there is going in your body, and it tends to cause the dissolving of calcium carbonate, which is what those marine critters are made of. Unfortunately, this component of the carbon cycle, the terrestrial photosynthesis, is beginning to fail. Let's dissect that. So we know that photosynthesis removes CO2 from the air. Plants also engage in respiration, where they release CO2 and water vapor to the air. So this is their metabolism, photosynthesis and respiration. However, photosynthesis has a thermal limit, a heat limit, and past that, it sharply declines, but respiration continues to increase. Carbon uptake by land plants becomes degraded under these conditions. And with continued emissions, carbon uptake may be degraded by nearly 50% as early as 2040. This effect is not accounted for in national policies. This is just 4 separate papers, and there are many more reporting on modeling and the observations and field testing of this effect. This particular paper says warming will lead to reduction of carbon assimilation capacity and eventually heat damage, as multiple studies suggest that a variety of ecosystems are operating at or near their thermal thresholds already. Let's look at Amazonia. The Amazon contains more than half of all tropical rainforest, but it is being logged, mined. There's hunting, deforestation, damming of all the rivers, drought and tree mortality happening. Combined, the Amazon lost 1/3 of all above ground biomass over the last decade. 1/3. 2010 to 2019, the Amazon basin released a little more than 18 billion tons of CO2, but only sequestered or drew down a little more than 15 billion tons. So the Amazon is now likely a net source of greenhouse gas. The darker the color, the more intense the human damage. More than half of Amazonia shows some type of human impact. But actually, this impact extends around the globe. Carbon loss from the entire tropical rainforest belt around the entire planet is increasing. From 2001 to 2005, based on satellite measurements, the rainforest belt released about 1 billion tons of carbon per year, but more recently, it released twice that amount, about 2 billion tons of carbon per year. 82% of this forest carbon loss is the result of agriculture. deforestation and turning over soil so that the carbon oxidizes. This paper says that strategies to reduce forest loss have not been successful. This paper came out in 2022. So these papers are still streaming out, telling us about the degradation of our natural carbon storage systems. Okay, so that was a whole lot of bad news. I want to end on an up note. If you look at global sources and sinks of carbon dioxide, so this is sources of carbon dioxide, and this is where carbon dioxide is stored. Prior to a decade ago, we were releasing or increasing our CO2 emissions at about 3% per year. But more recently, that has gone down, and our rate of increase in carbon emissions is less than 1% per year. After 200 years of fossil fuel expansion, we are at a turning point in the global energy system. Projections of future warming are 25 to 30%, 35% lower than just a few years ago. 3 degrees Celsius is now seen as a probable, I won't say worst case, but severe case scenario. A few years ago, I was talking about 5 degrees C and 6 degrees C. So there's been a vast improvement. Global carbon emissions growth has slowed. At least 18 countries have managed to cut their emissions consistently for over a decade. Renewable energy is getting cheaper. The world is set to add as much renewable power in the next 5 years as it did in the past 2 decades. Between 2010 and 2019, the cost for solar energy fell by 85%. And solar, on average, is 33% cheaper than natural gas. Wind energy costs fell by 55%. Investment is pouring into renewable energy at a record rate. Global energy demand growth will now almost entirely be met by renewables. The fundamental problem in our energy system is that every year there's demand for more energy, and that has been met with fossil fuels, which are already conveniently deployed and the infrastructure is already in existence. And so even as we deployed more renewable energy, the increase in demand outpaced that. And so overall, fossil fuel energy hasn't really budged from about 80 to 85% of our global energy needs, even though renewable energy has increased. For the first time, the International Energy Agency is projecting that 2023, perhaps 2025, we will see all demand for new energy met entirely by renewables. Jobs in clean energy will more than double by 2030, from 6 million to 14 million globally. Transitioning to 100% renewable energy by 2050 yields $12 trillion in savings just in the energy sector. The global market for clean energy manufacturing will be $650 billion by the end of this decade, triple of what it is today. New countries are passing climate laws. 91% of the world's GDP is covered by countries with a net zero target. All right, so that's the end of my global climate presentation. And now's an opportunity to take some questions before we go in to talk about sea level rise. Yeah, in the back.
Question on, it was the first slide regarding the amount of sunlight.
Right.
So can you explain, I'm having a hard time processing it with all the other, when we cut, the emissions, but more sunlight comes through, so it's warming up. So
the emissions are cleaner. They don't contain as much soot, sulfur dioxide.
right, but now we've got more sunlight, right? I didn't
Yep.
putting it all together.
So we're allowing more sunlight in because there are fewer aerosols to reflect sunlight.
Right.
So there's more sunlight, which means that the mechanisms that cause global warming are working with more feedstock, if you will, with more energy, and that accelerates the global warming process.
Interesting.
Did that help?
Yeah, I mean, I understood it for me, it's just putting it all together with reducing emissions and reducing chemicals in the atmosphere, but that's also led to sunlight coming
Yep.
through, which is counterintuitive.
Well, If the health benefits of cleaner air are enormous.
Sure.
And we are cleaning up the air even as we speak. Fortunately, it's a double-edged sword. We allow more sunlight in, but we are also gaining enormous health. Yes, sir.
I think I'm producing CO2. So everyone here is producing, the humans are contributing as the population of the planet goes billions and billions up. Are we making CO2?
So the overpopulation problem, the population growth problem is more significant in the expansion of deforestation in order to feed ourselves. The use of fossil fuels to warm and also cool our communities. That's a far more significant impact from human population growth than simply the fact that we are respiring CO2. That's a rounding error. That's very minor compared to the overall. Question, yes.
When you mentioned cows and corn or grass feeding, UH, I think, is responsible for inventing a seaweed supplement.
It's actually Australia, but you're right. We're getting on top of this problem. A seaweed supplement cuts down on methane production. And the word I was struggling with is enteric.
The map that you showed that had the heat areas and where populations aren't.
Yes.
How does that apply to Hawaii? So we seem to be in that same latitude zone.
So global climate models don't see the land of Hawaii. They are not powerful enough to recognize that small scale. And so we are engaged in what's known as downscaling. And there are two ways to downscale global climate models. One is called statistical downscaling, where you guide the model results by your statistical observations of temperature, rainfall from our gauges all over the place. The other is dynamical downscaling, where you apply the laws of physics on the small scale. You look at the results of those two types of climate modeling for Hawaii, they completely disagree. So we're not yet on top of being able to model effectively our climate inequality. It's a scale problem.
You said something about wetlands being a major increase issues. Are mangroves part of the problem? Or?
No. So mangroves are swept by the tides. They're intertidal communities. I'm talking about freshwater wetlands, where in the sediment pile of the wetland, you have a huge microbiome community, and those microbes are breaking down carbon and releasing CO2 and methane in the process. The major place where this is happening is in the Sudan. There's a large wetland there that has expanded massively.
Isn't it brackish?
No, I'm talking about freshwater wetlands. Mangroves can survive brackish conditions. They're very hardy, but I'm talking about freshwater wetlands in Sudan, as well as the Congo, and also in so. Yeah.
And are those wetlands intact or
Yes, they're intact. So one of the rules of thumb about warming the air is that wet places get wetter and dry places get drier. Well, these are wet places getting wetter, so the wetlands are expanding, so you have a bigger microbe community breaking down carbon.
I have a question from the chat. Actually, there was one about the seaweed supplement, but I'll skip that because that was already addressed. A question from John, who asked, there are reports that the hole in the ozone layer may be healing. How much does that matter based on where we stand now?
It matters, but it's one of the rare places where nature is working with us on this problem. It's not a huge effect. Don't sit back and think that it's going to go away because the ozone layer is healing. But it matters. It's helpful. Yep.
What can we do about sequestration?
Well, if you take CO2 and you dissolve it in water and you introduce it to volcanic rock, basalt it's called, that volcanic rock will weather and create a new mineral called calcite. your CO2 is now permanently sequestered in a mineral. They're doing this in Iceland, pulling CO2 out of the air. The company that's doing this is called Climeworks. It's a Swiss company. They're pulling 4,000 tons of CO2 per year out of the air. And they're working with the local geothermal energy cooperative, and they're injecting that CO2 into the ground. We need 10 million more plants, just like that one that's in Iceland, spread around the world doing this. And using the weathering of volcanic rock is just one way to do it. You can also inject it into sedimentary rock. So the entire continental shelf, the East Coast and the Gulf Coast could act as reservoirs, but they might be leaky. The best sequestration is volcanic rock, because you know you're mineralizing the CO2 rather than storing it in sedimentary rock, which might be leaky. And the science of pulling CO2 out of the air has been around since the 1930s. It just needs to be scaled up to industrial level, industrial chemistry plants. It's called the Faber-Bosch process. So there's a great wiki page on it. You can also take that CO2 you pull out of the air. If you make some green hydrogen, in other words, hydrogen that's made of renewable energy, you combine it with, you take that CO2, break it and turn it into CO, which is carbon monoxide, combine it with hydrogen, you can create a hydrocarbon. You can make diesel, gasoline, jet A, jet B, you can make any fuel you want. We can do that here in Hawaii, and as we become increasingly isolated with supply line problems due to climate change over the next couple of decades, producing our own fuels is one of the ways that we can increase our own sustainability. So basically, you're recycling the carbon in the air in doing this, because intercontinental air flight travel is not going to wean itself into either hydrogen or electrical for many, many decades. And meanwhile, we need to continue our tourism economy. So sustainable fuels, the best sustainable fuel is one in which you pull the carbon out of the air and then burn it, goes back in. Yeah.
The mineral you mentioned that is product of CO2.
Yep.
Is there any use for that?
Yeah, calcite is a component of cement. Even pulling the CO2 out, you can sell it to greenhouses. CO2 is a commercial product. So all of this has lots of investment potential. Okay, so we've had a constellation of satellites since the early 90s around the planet through a collaboration between the European Space Union, the European Space Agency, and NASA, measuring the ocean surface. Every 10 days, we map the ocean surface, and over time, differencing each of those measurements, we are watching the ocean surface rise. So this sea level rise has a long-term increase of about 3.5 millimeters per year. That's roughly a foot per century. But in the last 10 years, it has accelerated to over 4 millimeters per year. Excuse me. So sea level rise is accelerating. The rate of acceleration will currently take it to over 2 feet by the end of this century. Now it's going to continue to accelerate. So 2 feet by the end of the century is not a good planning target. Sea level is likely to be higher than that. Temperature change relative to the global average is shown here. So if we have our global average warming, the oceans are colder and the continents are hotter. This is one reason why I think Hawaii is the right place to be, because we are surrounded by a material that absorbs heat, whereas the continents are heating up. In the summertime, the continents are already reaching 4 degrees C and 5 degrees C. However, the oceans are colder than the air. So what are they doing? They're absorbing heat from the air, and they will be for thousands of years. What does water do when it warms? It expands. thermal expansion is the major component of sea level rise. It represents about 38% of global sea level rise. Warmer air is also melting the ice on the planet. All of these little colored locations are major alpine glaciers, and every single one of them is in decline. If you average all the alpine glaciers on the planet, you get an average that looks like this, representing about 21% of global sea level rise coming out of the mountain glaciers of the world. It's equivalent to about 281 billion tons of ice being lost every year. Greenland is melting. We measured these ice reservoirs using a satellite called GRACE. It measures gravity. GRACE stands for Gravity, Recovery, and Climate Experiment. So every time it passes over Greenland, it measures the gravity of Greenland. And we see seasonal snow and summer melt, and winter snow and summer melt. That's the gravity of Greenland changing, and you can see the long-term effect is down. We're losing as much ice from Greenland as we're losing from the alpine glaciers. So this is another 20% of global sea level rise from loss of ice on Greenland. Antarctica is surrounded by water, and it has it's rather immune to planetary climate change. And so for much of the last 20 years, it did not show melting, but as of about 2010, we're seeing a strong decline in the ice mass on Antarctica. It's representing about 9% of global sea level rise. The major area of concern is called West Antarctica, which is this area. There's a series of glaciers that feed into the ocean. All combined, they represent about 3 meters of global sea level rise, or about 10 feet. They have been accelerating the rate at which they flow into the ocean. This is the Pine Island Glacier. This is the Thwaites Glacier. A paper came out earlier this week that made a great conclusion. It noted that for about a 5 to 8 year period, the glacial discharge stopped or stabilized. And that was because winds were blowing offshore. Winds that had been blowing offshore had stopped. And so we didn't see as much warm water coming underneath these floating ice shelves, causing them to break up. The media is broadcasting this paper as collapse of these ice sheets is not inevitable. And that's wonderful news, because by the end of the century, multi-meter sea level rise, in other words, 4, 5, 6, 10 feet of sea level rise, is really going to be controlled by these glaciers, whether they collapse or whether they continue to melt much more slowly. So we're still learning things. And then you might be surprised to realize that throughout the 20th century, as we dammed up rivers, we actually mitigated sea level rise. We formed reservoirs filled with water that would have otherwise been in the ocean. But we've now dammed up the world's major rivers. And as we continue to pull fresh water out of aquifer systems and use it mostly for agriculture, and discharge it in the nearby watershed, it flows into the ocean. So now groundwater mining or groundwater depletion is responsible for about 10% of global sea level rise. The Intergovernmental Panel on Climate Change, every 8-ish years or so, comes out with a series of reports assessing the status of the science on climate change. Assessment report number 6 came out in 3 stages. The first one was the physical science about climate change. It came out in 2021, and it stated sea level is committed to rise for centuries to millennia due to continuing deep ocean warming and ice sheet melt, and will remain elevated for thousands of years. This is an important thing to really conceptually come to terms with. This is not fixable. This is not something that we can expect to go away. It's a fundamental condition of coastal areas, coastal communities. Their models indicate that we can expect 6.5 to 10 feet of sea level rise under 1.5 degrees C of melting. This is a long-term, many-century outcome. 6.5 to 20 feet at 2 degrees of melting, and ridiculous amounts of sea level rise under ridiculous amounts of melting that are not likely. Sea level rise is an unstoppable reality. How do we manage this? How do we plan for this? NOAA, NASA, US Geological Survey, and other science agencies have put together a series of scenarios for planning. The low and intermediate low scenarios are no longer relevant because it would mean sea level would actually start to go down in order for these scenarios to come true at the end of the century, which is here. So the intermediate scenario is the minimum scenario. And in Honolulu, it projects 4 feet of sea level rise by the end of the century. You would use the intermediate scenario for projects that have a lot of tolerance for risk. The intermediate high scenario is projecting about 5.8 feet of sea level rise. You would use that for projects that have a low tolerance for risk. Major public infrastructure projects, for instance. The high scenario, if you're going to build a nuclear power plant on the beach, have low tolerance for risk, and you want to design the thing to be still operating under very high levels of sea level. Well, all of this assumes that the West Antarctic ice sheet behaves and doesn't go into rapid melting, rapid collapse. That's a huge uncertainty here. This paper recently came out, which said that future sea level is tracking near the high end model projections. So, looking towards the high end. All right, so this is time, this is sea level, this is our classic first half of the century, this is second half of the century, accelerating sea level in the second half of the century. But the truth is that sea level is entering our communities with the tides, with the high tides. And we get these king tides that are occurring with greater and greater frequency as we approach permanent inundation, which is that black line. These king tides have already started arriving. Today, at the highest tides of the year, and that high tide, the gravity-fed drainage system no longer works. And if we rain on top of this, gravity-fed drainage no longer works. We want drainage pump. Because all the rain will be in the storms, onshore winds, offshore Oahu, which is water out. Rain can those winds create waves that groups happen. They tide under the tropical summer. Clearly, under little areas where Earth and Moon are more closely aligned, so your high tides are higher. So my research team has modeled this for this area. And I haven't discussed the fact that the water table under the ground here goes up and down with the tides. We have water wells. We have the leaky underground storage network, which the Department of Health has put monitoring wells at every gas station to see how much leaky underground storage of gasoline there is. We have gathered all those records together, thousands of records, and we have a very good idea of where the water table is, how many feet below the ground surface in our area here, and how it goes up and down with the tides. So we have modeled that with sea level rise. We also understand the storm drainage system. And we have coastal effects with water coming over the shoreline. So at 1 foot of sea level rise, which we can expect around mid-century, we're looking at individual drainage culverts being filled with salt water at high tide. And we're looking at, this is the lagoon in Hilton Hawaiian Village. We're looking at locations where you have new wetlands, which is what you make when the water table reaches the ground surface. So we have these small wetlands occurring. And we have storm drain backflow, where drainage culverts actually act as a source of salt water, and that's taking place in this area. Here is 2 feet of sea level rise. Change happens very rapidly after you get past 1 foot of sea level rise. We also have applied a transportation engineering criteria of when you have 6 inches of standing water, a small vehicle going through that will create a back wave which floods the engine compartment, and that vehicle is stalled. So you shut down that lane of traffic. So this is a no longer viable means of mobility. You can see shoreline flooding coming out of the Alawai around the golf course. Lots of failed individual culverts or storm drain sites. And at 3 feet of sea level rise, it really takes off. So we're looking at someplace 2080-ish, plus or minus a decade, maybe 2090. We're looking at the failure of dozens of storm drains. This is under blue sky conditions, by the way. Storm drains backflowing onto the road, creating flooding. Water coming over the shoreline of the Alawai, as well as the beaches, and shut down traffic for small vehicles. There's 4 feet of sea level rise, which would be, right now, our understanding to be the end of the century. And 5 feet. Make it rain on top of that. So rain at high tide. This was during the 2016 El Nino. This is Dillingham Boulevard. In the summertime, when the El Nino is strongest, in August and September, you have a lunar perigee. The tides are highest. You have a king tide. It rains at that time, and especially with an El Nino, you do get intense rainfall. This is the end of the day. This is 5 p.m., 6 p.m. These are all the workers in Waikiki trying to get home, trying to get onto the H1, many of them heading out to the west side. We know that many of these people didn't get home until 2 a.m. These are young families trying to get to daycare, pick up their children. And right, teachers can't leave until the last child is passed off. So that family is impacted. Waiting at home, you have other members of your family waiting for care. This is a very severe situation. Rain plus high tide we call compound flooding. Of course, there's coastal erosion and wave runup. So as the ocean rises, the waves run up higher. Under 1 foot of sea level rise by mid-century, a typical summer swell on the south shore at Eva Beach. This is not a storm wave. This is just a swell event. Runs up into the coastal homes like this. At about 2.5 feet of sea level rise, you see waves running up 2 blocks inland. And at 3 feet of sea level rise, every summer, with every swell event, you see the entire Eva Beach community getting washed by the waves. This does not count erosion, and there are seawalls along here. So we might still survive this by elevating all of the homes, by post-pier construction, but really, that's not very possible. So the Hawaii Sea Level Rise Viewer provides you with an erosion model result for 3.2 feet of sea level rise, which will be pre-end of the century. This is an 80% probability line. And then the wave runup, annual wave runup with swell events. In this case, it's the North Shore swell. So this district, called the 3.2 sea level rise exposure area, is being implemented in various forms of policy around the state. Now, the city and county has proposed a setback where measured from the certified shoreline or the upper reach of the waves, we measure 60 feet plus 70 times the annual rate of erosion, not to exceed 130 feet. How do we get the annual rate of erosion? So my team has calculated shoreline change rates. Now here is Mokuleia. Here's a vertical air photograph. We have these as digital photographs that we orthorectify. So we remove the distortion of these so that a distance on the photo is equivalent to a distance scaled to a distance on the ground. And we vector what's called the toe of the beach, which is the base of the foreshore of the beach before you walk out into the surf zone. And we've rescued thousands of historical aerial photographs, which we have also orthorectified. We vectored the location of the toe of the beach. We've also vectored the vegetation line. The difference of those is the beach width, which is a natural resource measurement criteria. And we also have rescued maps that were produced in the late 1800s for boat nautical charts. And we've identified the storm debris line and we've modified that. We've relocated that based on measurements of storm runoff compared to calm fair weather conditions. So you put all of these shoreline locations in our model. And for instance, here at Mokuleia, we have shorelines from 1928 up to 2006. And I can tell you we have 2 additional shorelines since then. And every 20 meters or 65 feet along the shoreline, we can look at the rate of change as a function of all those data points. So this particular transect has shorelines from 1920 up to present day. We fit a line to that. Slope of the line is the rate of shoreline change. In this case, it's negative. And at that transect, the shoreline is changing at 1.3 feet per year. This is the proposed setback in my EA. So if we take that 1.3 feet per year, just as an example, of course, it doesn't apply to LIEA. I'm just doing this for example purposes. 60 feet plus 70 times 1.3 feet is 151 feet. But the proposed rule is not to exceed 130, so the setback would be 130 feet. This is what 130 feet looks like, or actually, this is what 60 feet times the 70-year erosion rate. Why 70? That's the average lifetime of a wood frame house in the United States. That's what that number comes from. So here is the proposed setback on the North Shore. You can see it crosses many of the coastal parcels. Here is the proposed setback in Maili. Big blue line. Now, what are the setbacks in the other counties? On Oahu, our current setback is 40 feet, or for new subdivisions, 60 feet. And they're proposing this 60 feet plus 70 times the annual erosion rate. On Maui, the setback is the greater of 25 feet plus 50 times the annual erosion rate. This setback is now 20 years old. They were the first county to use a scientifically based setback. They are currently trying, or a lot depth calculation, I'll explain in a minute. They're currently trying to change the setback to an erosion hazard line, which is shown by this red line. And where they have a rocky shoreline, not susceptible to erosion, it's a fixed 200 feet. The Planning Commission on Maui has met multiple times. It looks like they're converging on a setback which would remove that 40 feet, but keep this proposed erosion hazard line from one of our models. Hawaii has the greater of the same as being proposed for Honolulu, or a lot depth calculation. This is basically a table where, depending on the depth of your lot, the setback gets greater and greater and greater. On Hawaii, the setback is just a straight 40 feet. And I'll end with that. Take any questions. Thank you.
Did you model Pearl Harbor?
Sorry,
Have you modeled Pearl Harbor?
no. I mean, we can do simple, it's called bathtub modeling, or you take a digital elevation model and you simulate 1 foot, 3 feet of sea level rise would look like. In fact, we were just helping Laura Thieling, Parks and Recreation for Honolulu. She wanted to know about Waipio soccer fields, etc. She wanted to see. So we do have some modeling. Yeah.
Thanks for sharing this information as depressing it is. This is minor, I guess, relatively speaking, but I'm not sure if you're aware of this, but in DLNR's wisdom, the first actionable item as a result of the new shoreline regulations that came about with SB 2060 2020 is to, in order to get a certified shoreline, you have to move your Naupaka Makai of the shoreline. So, you know, as architects, we're having to go through a lot of hoops that we didn't have to, and the intent is that, okay, we're helping preserve our shorelines, which I think we all agree with the concept. And so it really, you know, frankly, burns the hell out of me that the first thing we have to do is remove our Naupaka, which, you know, if you can tell me that's a good thing, then I'll believe that, but I doubt that's going to be the case. So I just, you know, I would love it if you could get with DLNR and go, hey, you know, this is crazy, guys.
So walk along Kahala Beach at high tide. And imagine if all the plantings there were removed and the fill that is also part of many of the lots were removed. And you go back to a natural shoreline, which would have a sand dune. And that shoreline is allowed to naturally receive the rising water. That's the idea that policy and other policies is trying to re-achieve. And Naupaka, beach morning glory to a lesser extent, the how trees, these have dense root systems, they're salt tolerant, and they tend to stay put even as sea level is causing the beach to get narrower and narrower. They're acting essentially as green seawalls. We need to get out of the way of the shoreline if you want to have a natural shoreline. And Naupaka, that if there's evidence of wave runup in the Naupaka foliage, then that's the ocean trying to tell you, you know, I want this to be beach, not to be vegetated. And Naupaka is a very aggressive plant. You know, within 3 years, you've got a whole jungle in there, salt tolerant, and it acts as a stabilizing influence on the beach. But the truth is, we need to let the land erode if it's sand in the backshore. All of Kailua, Waimanalo, that's all sandy. Kahala, I'm not sure, but I'm pretty sure it's sandy in the backshore. So we need to get out of the way, not against the DLNR policy. I know that, let me go to a more fundamental level. Stabilizing the shoreline is a bad thing when it comes to a beach. You don't want to stabilize it. Beaches need to be free to migrate because the ocean's rising. And if you trap that beach in that location with the ocean rising, the beach is going to disappear. We have an epidemic of disappeared and narrow beaches around Hawaii.
Understood with man-made hardening, but isn't the, you know, as much as the ocean wants to come in, which is a natural event, isn't the Naupaka growing also a natural event? It's something.
The Naupaka will, like I said, it's salt tolerant, it'll withstand wave runup, and it doesn't allow for natural beach migration. You won't see much Naupaka, for instance, on Papuhaka Beach, which is on the west shore of Molokai. That's my idea of a beautiful natural beach. It's wide, it has a great big dune system. That's what our beaches used to look like. We've mowed down the dunes so we can see the ocean from our living rooms. Plant grass. That's a huge sand reservoir that's now gone. And I won't go down this rabbit hole, but Naupaka gets in the way because it's so aggressively.
Okay, thank you.
Yeah. Thanks for the question. Yep.
There are a couple online questions. One of them was about this question, but we'll get back to that in a minute. So the first one received was, is there a good way for us to harvest the groundwater before it floods the streets and creates wetland conditions? And continuing on that, if we do nothing, won't the amount of drinkable water in the groundwater table be greatly reduced?
So our drinkable water comes from higher up on the Shield volcano. It's at higher elevation. And most of the hydrologists agree that sea level rise is not currently a threat to our drinking water because it comes up on the coast. While around here, it's up in perched aquifers that are not the aquifer that's underneath here. This is a heavily polluted brackish aquifer. So the water table here is not reflecting drinking water. What was the first part of that question?
Is there a way for us to harvest the groundwater before it floods the streets and creates wetlands?
So the geology of much of this area is an old fossil reef, which has big cavernous pores. You can pump the groundwater, but you're just pumping the ocean. There may be some locations where you have watersheds that have deposited alluvium, which is clays, silts, sand, and gravel. There are some locations where the geology would favor pumping the water table as a way to lower it. Generally speaking, it's this highly dissolved limestone with lots of caverns. So you can't really pump that because the ocean just fills in the air. So we need to learn more about the geology under here. We might be able to pump in certain restricted locations as an adaptation approach. But mostly I'm in favor of either filling or designing our buildings so that the first floor has a much higher roof and we can just raise the floor and learn to live with water. Yeah.
Since 1970, which would be 50 years or so, how much rise have been measured here?
Since the 1970s?
Yeah, 50 years.
Maybe a couple inches, not much. We're in a, so you know what an exponential curve looks like. We're still in that very slow portion. Okay. And all the models are saying, you know, the coming is not good. And in fact, as early as next decade, the 2030s, for lunar alignment reasons, king tide frequency is going to triple. We're going to see this flooding and king tides increase dramatically.
So far, it hasn't been.
So far, it's been an annual event. Yes.
There was a joint NOAA and NASA and whatever study that predicted by 2050 a 12-inch sea level rise globally. And I was wondering if there was any information that localized it to Hawaii.
That's exactly what I
we were going to get 12 inches. I mean, you know, I'm just kind of curious about.
No, I showed you that.
Oh, okay.
So that's called the Interagency Task Force. They gave us these scenarios.
Right.
And
so this is, okay, so if we go on that website or look at that.
Google NASA sea level portal. And there's a viewer where you can click your way down to the Honolulu tide gauge and every tide gauge in the US system. And this is taken from the Honolulu tide gauge. It's a screen grab from that website. Yep.
I have a question from the chat, going back to the previous conversation, was posted when we were discussing the natural shorelines and vegetation. Asks, what is a good solution then for the homeowners on the coast?
The homeowners on the,
Don't worry. It's called condemnation and the government paying.
so, yeah, you may have seen on Christmas Day, I had an op-ed in the Advertiser suggesting that there are 50 homes that are west of Sunset Beach Park. And based on their current property values, we could condemn them and buy them all at market value. What's that? $110 million. We have a budget surplus of almost $2 billion. We're proposing to buy out these homes and make a greatly expanded Sunset Beach Park. Since then, there have been 4 or 5 letters responding to that. 4 out of 5 supported that idea. One of them doesn't like it. I don't like it, frankly. I don't want my tax dollars going to bail out homeowners that have been ignoring the process of sea level rise, hoping for a better future. The answer to the question, in my mind, is This is a wicked problem. You planners know what wicked problems are. There's no good solution where everybody goes away happy. There are hard decisions that have to be made. I like to say that the golden era of coastal living is coming to an end. And it was great while we had those beachfront homes, but now we need an exit strategy. Nature is solving that problem for us. You all saw the house tip over on the beach several months ago. Nature's giving us an exit strategy. Are there other exit strategies that everybody can agree to? That's where some hard decisions happen. Yeah, I think from a planning standpoint, it's hard to implement managed retreat because you get voted out. But it seems like the insurance market is sort of driving managed retreat in some places where properties become uninsurable and property value. So First Insurance Company of Hawaii, the largest insurance company in Hawaii, does not insure beachfront homes. You can get them to insure your home, but the agent's going to visit and give you a special, customized rate. But just as a general practice, in fact, most of the large-scale global insurers, national level insurers, have backed away from the shoreline. After Hurricane Andrew in 1992 in Florida, they've backed away from Florida. The insurance in Florida now is a community-owned insurance company. And I remember in the early 2000s getting a note from my insurance company, Allstate or somebody, saying, you have 3 years and you're no longer insuring you because we're getting away from the ocean. And it's not just sea level rise, it's hurricanes as well, and storms. Yeah. So the punchline is that the shoreline is so attractive, and for people who have the money, they're still building there anyway. Insurance is not driving the retreat. Yes.
So kind of going along with this, there will be a retreat, but there's also going to be a period where people try to build houses on stilts. But then there's the sewer question of how is your sewer system in the same
Right.
area scaling?
Yeah.
You can't necessarily get to the pump, it's flooded.
Yeah.
Should take 2 times a month, whatnot,
Yeah.
tides. Like for the next, in 50 years from now, there'll be a substantial amount of properties around the state that are kind of in this limbo. They're not necessarily the beachfront properties, they're like 2 lots back. They're still getting inundated with tides. Is there any, I guess, do you have any ideas?
And I'm glad you're not dropping your mind around. I don't mean to be facetious, but yeah, you've laid out a huge problem. Just the in-ground sewage storage sewage system, cesspool, septic tanks.
What about the electric? If they're not watertight pipes, right?
That's
Or
correct.
they're underground. I mean,
Right.
you're talking about underground.
Yeah, I don't think there's a whole lot of underground electric, but some.
Like, Honolulu, there's not.
Yeah,
In this area.
There,
yeah.
the electric room of that building that you can see from here, just the opposite side of Sea Brewer, the basement of that building has all of their electrical systems in it. And the water level now is this far from the basement.
Yeah. There are pumps in the basements of buildings all across here.
I mean, we built basements in Honolulu like crazy. And they don't all work now.
The police station, what's that on? Veritania?
Yeah.
Main police station floods at high tide. They're in a parking garage.
Wow.
Royal Hawaiian Hotel runs 3 pumps in their basement. It's already here, it's already happening. Yeah,
I have another question from the chat. Melanie asks, how will sea level rise change when we account for more king tides and freeboard?
say hello to Melanie for me. I know.
Hi.
Sea level rise, we will see more king tides instead of 3 to 4 times a year. They're going to be occurring during those king tide months. They'll occur for 4 or 5 days until every spring tide, which happens every 2 weeks, becomes the equivalent in 2 decades of today's king tide. So the frequency of king tides is increasing. The height of king tides is increasing. What constitutes a king tide in the future, we have not seen yet. It's a water level that hasn't occurred yet. By the way, this sort of statistic also applies to heat waves. I haven't talked about heat waves. You may remember 2019. We set over 300 temperature records in the Hawaiian Islands. And we have an El Nino coming. We're going to start to see more of this incredible heat. So as designers, as community designers, shade is a fundamental feature of our communities. It needs to be. Porticos, awnings, Mediterranean, whatever, however you can build overhead shade, it's critically important. And I wish DPP would get on the horn and require this sort of shade. And then water fountains and any sort of water feature cools the air within 150 feet. So water features all over the place are very important. We need cooling mechanisms, and they can be beautiful communities. Cooling mechanisms for our communities. Yep.
You think that the science that you're sharing with us and reviewing is helping to set political agendas? Is there political resistance to science that we're hearing now?
In Hawaii, no, there's no political resistance. There is budget difficulty. There's the tyranny of the urgent difficulty, right? Long-term planning is difficult to wedge its way into the emergencies of the day. So that's the resistance. Nationwide, the answer is yes.
Yeah.
We don't need to go there, but in Hawaii, we're actually leading the way in several different sectors regarding change and adaptation. Yeah.
But do we have locally in Hawaii, do we have local policies that are happening to deal with the sea level rise and climate change? Because it feels to me like all the onus is being placed on like shoreline residents, homeowners.
It is. Yeah.
And but our airport, on and on and on. And with a meter of sea level rise, life on Oahu state ceased to exist as we know it. So I just don't see really.
Kind of a dramatic statement.
Well, okay, but if you can't fly in or out or harbor.
No, well,
it's
I
not
think there's enough
functional,
time.
Sewage, eco,
You know,
food storage.
Who's the new head of DOT? Anyway, he is deeply invested in climate change. So, and they have time to raise the reef runway and to raise, the runways. They know that they have to do this. The tools are out there, publicly available online as GIS layers from the Hawaii Sea Level Viewer. They're on it. But when it comes to the shoreline, when it comes to beaches, you're right. Government agencies are in a knot. They don't know how to move next. We have over 36 no longer legal sandbags or burritos just up on the North Shore. And they were allowed to exist for 3 years. That was a huge mistake. But they're all non-conforming. Legally, they could be removed, but DLNR is not doing it. And I suspect it's because the Attorney General is not backing them up on that. So we have a huge problem there.
But I'm glad to hear that the airport division or DOT is on top of it. It's time for that to be.
I'm assuming they are.
Okay. As the scientific community identified all the other problems aside from just coastal, power supply and food supply, and transportation, so on and so forth. Because it seems like there needs to be a much more global policy.
Yeah.
Beach homes.
Yeah. So, houselessness, homelessness, that's a climate issue. Let's say we get whacked by a hurricane. Will our community, under those desperate conditions, turn against itself or turn towards each other? Is our community a very stratified community in Hawaii, very wealthy, very desperate? The poverty level in the Alice population represent about half of our community. And those are the folks that are the working class. We get hit by a hurricane. Are we going to have an ugly situation in the community, or are we going to have a community that pulls together under those times of adversity for the next week or so? And we have the underlying cultural tools to do this, right? Aloha, love of the land for aloha aina, love for one another. These are fundamental tools that our society needs to be resilient. So early education, reducing the cost of living, houselessness, these are climate change issues that, once they're improved or solved, will build community resiliency to the shocks and stresses that come with climate change. So all the stuff that's on Governor Green's agenda, homegrown food, all that stuff, that's all relevant to meeting the climate change threat. And I mentioned fuels, that's often forgotten. We're going to need fuel, even though we are going to decarbonize. There's some things that will always need fuel for most of the rest of the century. Yes.
And we had one more question from chat. Bob asks, on the map that showed world areas that will become too hot for human living, Hawaii was on the edge of the map and too small to see. I think that was discussed. But areas shown are at about the same latitude. Is this an issue for Hawaii in the future?
Yeah, so it's the tropics. Our advantage is that we're surrounded by ocean water, which absorbs heat. However, there's a thing called a marine heat wave. When a marine heat wave settles in, which is what we had in the summer of 2019, you not only get coral bleaching, you get intense rainfall from the evaporation, but you also get intense heat coming out of the sea surface. So I don't see Hawaii as unlivable. I wouldn't characterize it as unlivable. I would characterize it as we need to redesign our communities to live with heat, to live with sea level rise, stronger hurricanes. That was sort of more hurricanes and strong. Yeah.
Are you aware of DPP updating their maps or policies to deal with like the king tides and the sea level rise?
So DPP is trying to increase the setback. That's a managed retreat from the coastline. There are two reports that I know of that DPP has put out. You can find them online. One is a review of other cities around the world and what they have done for, I think it's just sea level rise mitigation. And there's a companion report that talks about specific actions that we can do, that we can take. I don't think that they have instigated firm policies yet, might be wrong. You know, rail has been redesigned. Elevated rail from Chinatown to Ala Moana, if it ever gets built, was redesigned based on our sea level modeling, so that at 6 feet of sea level rise, if the roads were raised 6 feet, you would still have federal clearance for trucks. They uplifted all the electronics at the stations so that they're above 6 feet. Kirk Caldwell made a mayoral declaration that all the city planning will recognize 6 feet of sea level rise and take that into account in CPP projects and other things.
Probably necessary shoreline hardening.
What was the beginning? Necessary shoreline hardening? Absolutely. Seawalls can work very well. We need them in our ports. I think around the airport. I just think that where we have beaches, they've already been subjected to enormous seawall construction. We want to protect our beaches.
The studies you were doing, is that kind of to try to encourage specific areas of the island to protect beaches? Like,
yes, so this
limiting shoreline hardening around existing.
Well, the studies with the transects was designed to get rates of shoreline change so that we can develop policies to get out of the way of erosion threats, because it's erosion threats that trigger seawall construction. So we wanted to have the basic scientific data for policies to get us out of the way. And there are other states that use the same sort of thing. And we started that because in 1996, the National Academy of Sciences came out with a study that said, hey, you want to get the rates of erosion for all your beaches and develop policies around that. So I saw that and I said, hey, that's a great idea. Let's do that.
Then with the shoreline also there's, I guess, effects that having a hardened. Like you said.
Yeah, there's a thing called flanking, where if you build a seawall, your neighbor's going to start eroding. And if they're already eroding, the rate of erosion may triple. So then your neighbor builds a seawall, and that guy, and there are entire coastal neighborhoods in Hawaii that started with one seawall in the 1950s, and you just get this domino effect. The beach all disappears, and it's called flanking.
Is the university system prepared to educate the youth for degrees for this future?
The entire US education system is way behind. Right now, it's falling on individual professors to design courses to this, and also individual professors who are collaborating with other departments to create various types of degrees. So in my school, we're currently planning a Master's of Arts for as a professional degree, where you could take courses in the evening or lunchtime or summer and learn about climate change. So whatever it is you do, you'll come away with credentials understanding climate science. A lot of companies these days you may have heard of tier 1, 2, and 3. That is cutting down your greenhouse gas emissions. We'll provide training in that so that you can be the expert for the company to know where all the greenhouse gas emissions are, cradle to grave emissions associated with stuff that we ship in, et cetera, et cetera. But we're being led, it's a grassroots. That's the case in most universities. It's unfortunate, it's very slow. It should have been 20 years. Yeah.
It seems to me Hawaii is a very, very small part of the global climate change problem.
Yeah.
And that doesn't mean that it shouldn't take responsibility for its own actions. But sea level rise, it doesn't matter what we do here. In essence,
I know where
sea
you're going.
level rise and everything else is going to happen. And what I'm wondering about is, has there been anything that has said, well, okay, by 2015, you're going to have to raise all of the airstrips that have to be raised by a foot, or something that lists all of the anticipated changes, which I'm hearing are inevitable.
Yep.
So
There's a law that requires every agency to look at sea level rise and to assess their future needs. So the answer is yes, doesn't exist yet. I think that law was last year.
Oh, okay, so that's being worked on.
Yeah.
That's a state.
I thought you were going to say, why are we spending money on mitigating our greenhouse gas emissions when
No.
doesn't matter? The answer anyway. The answer is because number one, it's moral. Right?
Oh, of course.
We need to join the team, so I go, sure. We need to join the rest of the world. And number two, this is a big one. We can show the world what a significant sized community can do in terms of mitigating and also adapting, and thereby save ourselves by showing the world to get them to change.
Yeah, I want to know, though, practically, what needs to happen in Waikiki to keep the every single hotel there from going out of business? Because there's water 1 foot or 3 feet deep over the entire area.
Well, first of all, Ko'olina has an additional 2 meters of elevation. So Ko'olina sits up on a limestone plateau and they're not experiencing any flood.
Okay,
But maybe.
but Waikiki does not have the same.
Right. Second, one problem with all those hotels is the GMs of those hotels cycle in for a decade and then they leave, generally speaking. So we don't see the level of investment in local community, generally speaking. Third, you can either raise the land, if we can excavate, fill, and literally raise Waikiki, which we did already prior to World War II with the Alawai dredge. It was raised 2 feet. You could do that. And fourth, redesign your hotel so the first floor is floodable, living with water, etc. Then there's the 4 basic components. There's the building stock, there's the transportation, there's the open space, and there's buried infrastructure. They all have various types of solutions.
Yeah, I'm just asking if there's been any document here that says, we're going to need to do these things.
You're looking for a plan? Not yet.
No, that's what I'm
Volunteering?
I got it.
I've been advocating for a $5 million study funded by the legislature that would go to a consortium of local planning companies to come up with a plan.
But
We
one
just
plan,
our time.
one plan was the raising the rail 6 feet.
Yeah.
And other similar things. What does that buy us? Is that a 50 years? Is that 100 years?
It's like 100 years.
Yeah.
Good enough.
Making predictions is hard, especially about the future.
Yeah.
It depends on the West Antarctic ice sheet. You want me to end?
I'm sure that we could all talk to Jeff all afternoon. We just did our time. Please give him a round of applause.
It's for a great question.
If this session resonated with you, as an architect, remember that we have our AIA 2030 series that's starting on February 7th. So please sign up on our website.